This is Anthony Priscilla doing some more sum and difference trigonometry with my trig class. So this one says use the cosine of a sum and cosine of a difference identities to find cosine s plus t and s minus t. It's hard to read. I'm about to rewrite it. It says sine s is negative 5 over 13, and sine t is negative 3 over 5. We're told that t is in quadrant 3 and s is in quadrant 4. So quadrant 4 over there, quadrant 3 here. Well, if we're going to find cosine s plus t or cosine s minus t, then let me skip a little room and write out what we're going to need. It says find cosine s plus t and cosine s minus t. Thinking of the identity, cosine s plus t, that would be, okay, what's that old pattern? Cosine, cosine, change, sine, sine. I sort of wish they'd used A and B rather than S's and T's. I think they like the sins and cost showing there, okay? But we're using S and T for some reason in this problem. Well, there's a few ways you could do this, or several ways I should say. Right off, we know sine s. Sine s we were given. It's negative 5 over 13. Negative 5 over 13. And we also know sine t. Sine t is in negative 3 over 5. Well, okay, too bad we weren't told cosine s and cosine t. But we were given enough information that we could find them. And there's a few ways you could do this. If you want to go ahead and use the Pythagorean identities, sine squared s plus cosine squared s equals 1, okay. You know, I'm all for identities, but not for this. What I would do here is use that original x, y, r definition that we used, or that we first used to define these trig functions. In terms of x, y, and r, sine would be y over r. Now, what I'm about to do in green is going to take into consideration this quadrant 4 stuff. We're told that we're in quadrant 4. So in quadrant 4, what are the signs of x and y? SIG in sign. What are the signs of x and y? In quadrant 4, that would be positive x, negative y. So we know x should be positive, y should be negative. The stuff I just did in green is all the only time we'll use this quadrant 4 stuff. Now, using the x, y, r definition, sine is y over r, so that minus is on the 5. We know the minus can't be on the 13 because r is always positive, always positive. So now, I'll use x squared plus y squared is r squared, and solve this thing for y. Let's see, solve it for x. We'd have x squared plus y squared. Let's go ahead and do that in our head. Negative 5 times negative 5 is 25. R squared, that would be 13 times 13, 169. Yep, so subtract the 25. So we have x squared equals 144, and I should have left a little more room here, but I heard someone say it, x is 12. We're choosing positive 12, and that's correct. X should be a positive number, because you're in quadrant 4. If we had been in, say, quadrant 3, we would have had to say x is negative 12. But by knowing that x is 12, we can fill in this cosine s right here. We'd write 12 over what? 13? Now, go through and do the red just like that. The sine t, x is, well, do the green, take care of the green. Quadrant 3. In quadrant 3, what do we know about x and y? They're both negative? So, sine is y over r, so you'd write negative 3 is y, r is 5. Now go through, do exactly what we did over there. X squared plus y squared, negative 3 times negative 3, 9, is r squared. Subtract the 9. And now here, this is going to be tricky. We have x squared equals 16. What square root are we going to take? The positive square root or the negative? Negative. Why? Well, quadrant 3. So x is negative 4. Negative 4. So now we're ready to fill in this spot right here. Cosine t is x over r, so negative 4 over 5. Now it's just a matter of doing this arithmetic. Let's see. I'll just do it in black if I can find it. Let's see. 12 times negative 4 is a negative 48. So we have negative 48 over, is that a 65? 15 plus 50. Then, be careful with all these minus. There's this minus sign. And then negative times negative is going to be positive. So is that going to be a 15 over 65? Which will combine together. Are we getting a negative 63 over 65 on that one? I'm thinking negative 63 over 65 is right on this one. Now, oh wow, we've done one of the two parts, but actually I think we're almost finished. Okay, we still have to find cosine s minus t, but how would that change? Cosine s minus t. Where would I need to change this? Find cosine s minus t. We'd still have the cosine. Change. Okay, so you change that middle sign, right? Cosine, change, sine. So that would put a plus right. See if you can follow where I'm saying we would change it. There'd be a plus right here, which would put a plus right there, which would put a plus here. Would it be negative 48 over 65 and a plus 15 over 65? Are y'all caught up here? So a negative 33 over 65. This is the lazy teacher way of doing that. And then showing all the work again. This minus right here would change to a plus. Plus. Okay. Any questions there?